Hi, everyone. Welcome to the SWAN webinar. Thank you all for joining. We still see some people funneling in, so we'll give it about 20 more seconds and then go ahead and get started.
Hi, everyone. Welcome to the SWAN webinar, Generating Digital Twin and Energy Sparks. An appropriate name for Valentine's Day today. I hope all of you who are celebrating Valentine's Day have a wonderful day, and this is a good way to get started. We have amazing speakers that are case study driven webinar for you. So let's get started. Want to go to the next slide? So first of all, I want to make sure that everyone's aware of our annual conference. It's going to be in Vancouver in May. We hope to see all of you there. And the next energy efficiency call, call number 3 for this new community of practice is optimizing your asset lifecycle. It's going to be on March 14th. We hope everyone will join that call and bring your ideas to it. And let me introduce myself. I am Gigi Cormus-Edwards. I'm the CEO and president of Cormus-Edwards Consulting. I'm also the co-chair of the Digital Twin Working Group, along with Andrew Fargas. We have been running this Digital Twin Working Group now for almost 4 years, since 2019. So I hope you guys can join some of the discussions on Digital Twin. Darren?
Thank you, Gigi. Carmen, can I ask you to introduce yourself, please?
Thank you, Darren. And hi, everyone. I am Carmen de Miguel, leading the strategy for the water and wastewater segment in Schneider Electric. And with Darren, we have started this energy efficiency community of practice about 1 year ago. So Darren, if you can introduce yourself, please.
Of course. So Darren Coleman, I'm a system performance manager at Anglian Water. I'm really proud to be leading this kind of group around energy efficiency and the community of practice. It is all around benchmarking, sharing best practice across to really try to target some of these kind of real good layers around zero emissions, net zero, all of these key milestones where we're all heading to. So yeah, really looking forward to our next call. On the 14th of March, please join us. Thank you.
Yeah, and Darren, when we were considering how energy efficiency, is covered within SWAN, you and I, if you remember, we were having some conversations, and we really missed some dedicated group or slot within the SWAN community to address the needs of the industry by digital. The energy efficiency, carbon, all these targets that the industry is challenged to achieve can be supported and facilitated, addressing them by smart water solutions. So from field services, field devices, monitoring, automation, all the layers that we see in the SWAN ecosystem, we were missing some piece dedicated to the energy topic, and that's why we are here today, and we have connected with our colleagues in the digital twin. So in the community of practice, we started less than 1 year ago. We have had a couple of quarterly calls, next one in March, and we are excited to welcome more participants, right?
Yeah, I'm really excited in terms of digital twin and where that kind of takes us in terms of energy efficiency, either through simulation of process, whatever it needs to be, to try to focus around energy efficiency and kind of connections and collaboration across the whole of this sector. So really looking forward to the rest of the webinar. Thank you.
Great. And additionally, we consider that our 2 communities of practices can be reinforced by increasing collaboration to like extend or enlarge the scope of the digital twin with more applications like energy efficiency and a few others. So that's all from our side. Let's go ahead with the session today, which is really interesting, and we are looking forward to that.
Thank you so much, Carmen. It is very exciting. And I think the combination of digital twin and energy efficiency go really hand in hand. And we're going to hear a lot about that today from our expert panelists. We have Sharon Hamilton, Intelligent Control Center Manager from Scottish Water. Then we have Min Zhang he's a Manager of Information Management at NEOM. And Otto Ecke from the Product Manager and Developer Twin Wastewater from Royal HaskoningDHV at DHV. So this is going to be very exciting, and I'd like for Sharon, why don't you go ahead and get started?
Yeah, good afternoon, everyone. I'm really happy to be here, and unfortunately, technology has let me down this afternoon. So my camera is not working, but I'm assured that you can all hear me loud and clear. It's a real privilege to be asked to join the forum this afternoon, and I hope you enjoy what I've got to say. I've got some slides that I want to go through, and really just to tell you the story of how we've implemented real-time energy management here in Scottish Water. So I'm just going to share my screen. Okay, so I was actually going to start this off by saying good afternoon to everyone, but I appreciate there's a lot of you homing in from other areas across the globe, so thank you for taking the time to join. And what I want to share with you is just our experience of taking a bold step, in our opinion, of implementing some digital twin technology into our Intelligent Control Centre here at Scottish Water, but also how we went about doing that, the difference that it's made, and just what our plans for the future are, taking the learning that we found from this. So first of all, I'd just like to tell you a bit about our Intelligent Control Centre, or our ICC as it's known, and I know there's maybe some of you on the call today that have had the opportunity to visit us. We are based in Glasgow, Scotland, and we are the National Control Centre that looks after over 4,300 assets across Scotland, taking care of public health, the environment, and the health and safety of our people as well. And we've already got a really great story to tell. And I think that the journey that we've been on is pretty incredible to date. So it was formed in 2010. And it started off as a very simple control room. And I have to confess, in the early 90s, I did actually work in there as a radio operator. And it's been really great to kind of go full circle throughout my career, and now come back at a really exciting time when we want to drive a transformation journey and to be able to lead that into the future. So what started off as a really simple control room has built capability and maturity over time, and we provide critical services right across Scotland. And technology has been a big part of this for us. And I actually remember the very first telemetry system being brought in there. So don't do the maths, but that was quite a wee while ago. As we built our maturity, the main focus has always been for us was about reacting and responding. So we've not really had the technology that's given us early information to make intelligent decisions. And part of our future transformation is very much to move from a place where we react and respond to becoming much more predictive, preventative, and using lots of information to allow us to make those intelligent decisions based on evidence. So just very quickly, an overview of some of our activities. And it's a very fast-paced environment, and it's very reactive a lot of the time as well. And this slide just gives a bit of a sense of the kinds of activities that we undertake in the control room. But the one thing to note is that we get in over 3.2 million telemetry alarms in the year, and our aspirations is to move that to a much more manageable position that allows us to use technology and digital twins to enable us to equip our people with the right systems and information to allow them to do their job much easier and help us get much more on the front foot when it comes to managing risk. So I've talked about transforming for the future, and I'm being quite specific here. We've got a new chief exec. He is very much about us being bold and taking bold decisions, and I'm really proud to say that that we have in the ICC taken some very bold decisions. And the slide that's in front of you just now is just an example of a number of different initiatives that are part of our transformation programme at the moment. And one of the big focuses that we have is about building the maturity of our asset base and making that much more intelligent. So at the moment, we have got a number of initiatives underway, and a lot of that is focusing on building water and wastewater sensor information so that we can gather data from the asset base and join that up with other pieces of existing data that we already have in our ICC to help inform what's happening right across the system, give us insight into asset health and also emerging risks so that we can ensure that we are delivering the absolute best service for our customers. We also have a big aspiration about implementing remote management, being able to make interventions to prevent issues happening and also to drive down the need for us calling out our people in the middle of the night, etc., to deal with emergencies. So a number of initiatives underway right now, very exciting time, but the one that I've chosen to home in on is Aqua Advance. And this is a system that we chose to pioneer in the ICC pre-COVID and pre-transformation programme as well. We started our plans very early, and the aspiration that we had was to implement this system into what's known as the Lomond scheme. So the Lomond scheme is basically the largest water treatment supply zone in Scotland. It has a throughput of around 190 megalitres a day, and the clear water tanks at the Balmore Water Treatment Works hold over 5 million gallons each. So it just gives a bit of a sense of the size of the treatment works. As I said, it's the biggest water supply zone in Scotland. It's based in the west of Scotland, but pushes water out as far as the east of Scotland and the south. And in Scottish Water, we are actually one of the biggest users of energy in Scotland. You know, we've got one of the highest electricity bills out there. And the focus of the Lomond scheme has always been about managing interventions manually. So looking at levels in tanks, etc., and taking decisions to operate the system. And that has been done in an inconsistent way in the past. So we have 24/7 shifts within the Intelligent Control Centre, and each one of those shifts would maybe have their own way of operating the system and making decisions. So the focus was always about risk, never on energy. And in terms of the work that involved, there was over 2 hours of administration work every single day for the team in ICC. But we're aware that, you know, there's inefficiencies there. The world is changing. We have to become much more responsible in how we use power, how we take care of the planet. And we saw an opportunity to implement digital twin technology in the form of Aqua Advance. And one of the decisions around this was not just about us bringing in some new technology into the control room. It was very much about asking ourselves, why would we want to do this? So I've already mentioned about let's start to move away from just focusing on risk and start to focus much more on how we can take care of the environment and reduce our energy consumption around how we operate the Lomond scheme. Also gave us an introduction to automation in the control room. I mentioned earlier that we get lots of telemetry alarms, etc. We want to do as much as we can to bring automation in to try and reduce the amount of manual tasks that we do, and also take away some of the decision making from our team to really help with their well-being and free up capacity to do other things. And something else that I'm sure everyone on this call is really passionate about is how do we optimise our asset performance? You know, we don't have all the money that we would need to make sure that all of our assets operate as best they can, but we need to get into the space of understanding asset health and taking steps to operate them differently so that we can extend life cycles and perhaps even save, you know, customers money and reduce the need for reactive investment in the future. And I've mentioned a couple of times the word well-being. For me and for the wider Scottish Water, that is absolutely something that we are very passionate about. It's taking care of our people and recognising that technology is not just about the shiny new tools. It's about how can we help people to do their job better and make it easier for them as well. And this system also gave us the opportunity to start exploring new ways of working in the ICC as well. And overall, it took us about 2.5 years to get to where we wanted to be, a wee bit later than we had anticipated. And I'm sure you'll relate, the pandemic had an impact on that. But we've now had Aqua Advance in the control room as business as usual for almost 2 years now. And there's been a significant impact, very, very positive. We have heard lots of really great testimonials from our team in the ICC, who sometimes feel like there are new systems coming in all the time and it feels like more work for them to do. The experience that they've had has been the absolute opposite. It's freed up time for them to actually really, be able to spend time analysing information and making other decisions and allowing us to do other work in the control room as well. What I'm really proud of, though, is that we have absolutely managed to reduce our energy consumption. And since we implemented Aqua Advance, we've had a reduction of over 1.2 million kilowatts of power usage than we usually would have, just based on this one system and the one supply zone that we're looking at just now. And we've made cost savings in excess of £145,000, equivalent to $182,000. And it's also improved well-being. And whilst I can't prove it yet, I have no doubt that we are absolutely in the space now of being able to understand our assets better, and we will be able to extend the lifespan of those. We are already operating our system much more effectively, much more efficiently. We are seeing less failures. And the next stage for us here is to try to understand, has there been an impact in the reduction of the need for maintenance of the assets on this loan scheme? And I think something else that's really important to mention is the change experience that we give our people. We have done a lot of research here in Scottish Water, and sometimes it's quite disappointing to hear that the experience of our people is that we're not very good at implementing change. And I think there's been a lot of learning for us here, and we've taken an approach that we haven't just implemented a new system. We've really thought about, what would this mean? Why are we wanting to do this? And how do we support our people and the wider teams to make them feel that this is something that's been brought in to help them? And that's the feedback that we absolutely get here. So Aqua Advance Stage 1 has been the Lomond scheme, but there are plans to roll this out in other schemes across Scotland. And from my perspective, the more of this digital twin technology that we bring into our intelligent control centre can only be a big benefit for us. One of the challenges that we do have is about separate systems and the amount of systems that we have to look at from the control centre perspective. And there's work that we're doing just now as part of our transformation programme, looking at how can we visualise that information much easier so that we don't have to go into separate systems all the time. But overall, we have seen a real benefit from the introduction of Aqua Advance, and anybody that wants to ask any questions or catch up with me after this session, I'd be more than happy to spend some time with you. And I just want to say thank you very much. I hope you've enjoyed that. Okay.
Thank you, Sharon.
Thank you, Sharon. That was excellent. I think next we'll go to Otto.
Yes, I will share the screen.
Thank you.
And Otto, you can just reshare your video.
Oh, it says, it still says you cannot start your video because the host stopped it.
Oh, apologies. I will get that up. You can go ahead and get started.
Yeah. Yeah, so today I will demonstrate two use cases of the application of an operational digital twin. Yeah, with the aim reducing energy consumption, as well as reducing N2O emissions. And of course also improving the effluent quality. So why should we apply a digital twin for these goals? Well, first of all, it's something that you can add on the existing solutions without help building or constructing or expanding the wastewater treatment plant. And one of our findings during our N2O research is that a good control strategy can really have benefits in reducing nitrous oxide. But besides that, a good control strategy can also help in improving effluent quality, especially with the stricter regulation everywhere occurring. And of course, it can also help in saving energy. And if you dive into this problem of the processes, how they actually perform, you see often that processes are controlled in a very reactive way, responding more on what has happened than anticipating what will happen. And by making use of predictions from artificial intelligence, but also using domain knowledge principles, you can be able to anticipate on the major impacts of the process. And in a digital twin, you can arrange that and you have the prediction for the processes, and that you also can prescribe set points for these processes. And that all can start with, for example, determining the major impacts on the processes. As some impacts you can easily predict, like, for example, the dry weather flow to a plant. Other impacts like rainwater flow conditions you can detect. And even side streams on a plant from return flows from the sludge line are impacts you can handle. And if you then also apply algorithms to predict and to learn relationships within the plant, you are able to anticipate instead of react. You can predict how you should control the plant, and meanwhile you can also read, of course, the online signals, the measurements, to also do the fine tuning and correction at the end. And all that together delivers you a solution that continuously learns and stabilizes the processes, which is beneficial for the process itself. It's better operatable, but also that, for example, the effluent quality is more balanced between ammonium and nitrate, or that you can minimize your set point changes, which is, of course, also interesting for reducing N2O emissions and reducing the energy consumption. So being in control and being able to predict the process and to prescribe set points based on that can be very beneficial for your process. So our use cases of today are within the Water Authority of Vlaai-Veluwe in the Netherlands. And this water authority has 1.2 million inhabitants. And their area, as you can see, includes also several wastewater treatment plants. Of all kinds of sizes and types. And on these plants, we are running 15 twin applications, some for the network, some for the water line of the treatment plant, and some for the sludge treatment. And today we will focus on two use cases for the plant of Amersfoort and also the plant of Soest. Where we have done recent research and also the performance or the impact of the applications on the targets we have in mind. At Amersfoort, we really focused on effluent quality and energy savings. Fly and Veluwe experienced here at this plant that it can be quite challenging regarding the nitrogen in the effluent. And the idea was with control that we can stabilize the effluent quality and also improve the effluent quality and again also save energy meanwhile. And at Soest we executed a research plan where we focused on measuring N2O and also to check several hypotheses regarding N2O, which one also consisted of a comparison between the local control and the advanced control of the digital twin. So if we zoom in to Amersfoort, then the targets were to have more an autopilot solution, which should deliver a smoother operation for the process operators, and also to stay within the total N smaller than 10, and also to have the energy usage reduced. And for this, we executed an experiment where we changed between the local and advanced controller, and also did analysis on the impact of this. So for several parameters, we researched the impact, where we concluded that we were able to improve effluent quality. And also especially that for one of the aeration tanks, we were able to make a major reduction in energy consumption for aeration. Based on these results, we were able to say what the exact impact of the advanced control was. And of course, we also during the research, we of course also had some other experiences which we still could improve at this plant. For the Soest case, we did several analysis regarding N2O emissions, and one of that was also comparison to do within the PLC and APC control. And especially during the higher loaded period, we were able to see difference between the values for N2O with the advanced controller compared to the local controller. So we saw there a difference of 1/3. And besides that, we also noticed that there is a very clear relationship between the daily dry weather flow pattern to the plant and the values of N2O. So you see that in the process when there's more load coming in, you see that then the N2O occurs, and that you then also can make a difference with the controller. The conclusion is that digital twins can really help in achieving goals regarding effluent quality, emissions, and energy. But that also having clear goals with the digital twins is very important. And besides that, also that robustness and adaptiveness of the solution is very important for also the operators. So having the algorithms being able to run independently without intervening every time, that's a very important aspect. And yeah, as we saw at these locations, yeah, intervention was not necessary in operation. And also a very important aspect of yeah, implementation of the digital twin is that the functionality is explainable to the operators, and also that the set points are traceable for the operators, so that the operator can derive what the controller exactly has prescribed, but also is aware of the mechanism that's being used coming to the set point. So that is a conclusion of these use cases. Yeah, and I would like to thank first of all Flying Veluwe for offering the opportunity to do the research on N2O, and also supporting with the experiments on Amersfoort. And I would also like to thank Ellen, my colleague, who assisted with all the N2O research, and also the SWAN organization for yeah, having this great opportunity to share these results. Thanks.
Excellent, Otto. Thank you so much. That was a great presentation. And all of you listening, please make sure you put in some questions. I mean, there's a lot of questions that came to my mind, and I'm really looking forward to the discussion afterwards. So thank you, Otto. Next, let's go to Min. Min, would you like to share your screen?
Hello, hi. Yeah, just share my screen.
Thank you. Very exciting talk so far. Looking forward to this one as well.
Okay, great. Can everyone see the presentation screen?
Not yet, Min.
How about now?
No. Shayna, could you help out a little bit?
Absolutely. Min, I do have your presentation up if it's helpful. Oh,
Here it goes. Here it goes. All right. Fantastic. Thank you.
Okay, I'm just putting presentation mode, and okay, this is all good.
Perfect.
Okay. Right. Hello, everyone. My name is Ming Zong. So I'm responsible for project information management at NEOM. NEOM is the energy and water utilities organization, which is part of the wider NEOM company. And yeah, today I would like to share some of our experience in terms of implementing the design phase digital twin, as well as our attempts of using digital twin as a technology platform to capture greenhouse gas emission data as part of the initiative. So, well, in terms of NEOM projects, we are, unlike other water utilities, we are very much a greenfield environment. So the priority at the moment is to deliver assets. We do not have typical residential customers as such. The objective is to develop anything ranging from assets ranging from desalination to pumping stations to wastewater treatment facilities, as well as transmission pipelines to support the rest of the construction and development of NEOM. So we have divided our project delivery lifecycle into 5 stages. And typically starts with stage 1, which involve such activities such as initial asset brief, land use permits, and project definition reports, and it follows all the way to operation and maintenance. And this is where what we refer to design phase digital twin comes in, where in the middle of it, the stage 3 and 4, where typically is tendered to PMCs and EPC contractors. And this gives us a digital thread, allowed us to collaborate and work with our PMCs, designers, suppliers, technology providers, and work on that common platform to ensure that the asset that is being built and being delivered on the ground is according to design, and there are minimal amount of site alterations and changes. So just to highlight some of the functionality of the design phase digital twin, it provides a platform for us to validate our design, as well as incorporate hydraulic model optimization, and to really allow us to efficiently design and operate our water assets. Now, in addition to that, we have incorporated BIM model information. Now, this is typically submitted by our designers and the contractors, and this allowed us a common platform where we're able to comment and review and making changes to the BIM model together on the same set of platform to ensure that the level of detail and the integrity throughout the project delivery lifecycle. Now, finally, we have also incorporated reality capture, this including on-site asset visualization to be able to see and monitor on the day-to-day and a week-by-week basis of the development that's happening on the ground. So this provides an immediate reflection of the construction activity. Now, I'd like to take this opportunity again to thank our partner, which supported us through this implementation of design phase digital twin, especially Gigi here, who really has helped us to pull everything together and to implement this digital twin environment. And thanks to the partner, we're able to create a comprehensive set of fully integrated system that work together as one single platform to make those functionality a reality. Now, one of the interesting things immediately after implementation that we see is technology and software application tend to be very mature nowadays. That there doesn't seem to be a lot of challenges to implement technology. However, to ensure the data that has been collected as part of the project delivery lifecycle and the data that we get from our suppliers and vendors seems to be a critical element when it comes to the quality and the information that is reflected in the digital twin. So immediately after implementation of the digital twin, we started looking at some of the more fundamental requirements and specification so that we can continually improve and again work with our PMC and contractors to ensure that we get a consistent feed of data and information. And this is where we created the water asset data framework. Now, this includes a set of procedures and specification, such as the asset naming and tagging procedures, the 3D model BIM procedures, as well as set of project information requirements. And it goes across into the people elements as well. That's, as you can see from the top, that's on the purple box, we also created the project information management team that continually work with the contractors and with the internal business units to define that information management strategy, communication plan, have this continuous educational process with our contractors to ensure that the model, the drawing, and the GIS references are compliant to the NEOM requirements. Now, further to this, we have adopted a particular standard, which is called CFORCE standard. Now, again, like I said, we are in a very much greenfield environment. Now, the CFORCE standards, it works and makes sense to us because it is it's a specification that is used for delivering capital projects. So CFORCE stands for Capital Facility Information Handover Specification. By adopting these standards, it gives us almost a shortcut, a very quick way of establishing our asset data model and provide a whole set of reference data library that really down to the detail of the equipment level for us as a client to be able to ask to a granular detail of what information attributes, classification of equipments are needed, as well as be able to further strengthen our digital twin environment by providing a set of software implementation requirements. And this allowed us to quickly transition from a greenfield asset delivery environments, and to be ready for operation startup, maintenance activity, or in some cases, decommissioning some of the older assets that's around NEOM region. Now, moving on to the areas including the greenhouse gas emission. Now, so here at NEOM, we looking at the GHG protocol and identify that 3 groups of emissions. The emissions that also known as scope, as I mentioned, that which is defined at the greenhouse GHG protocol website. So the scope 1, which the emission that are direct effects that produced by the organization. So for example, this including the venting, leakage, waste treatments, and the fuel combustions. And the scope 2 are the emissions that occurred while consumption of electricity, steam, heat, or cooling. Now, these are typically generated not at the water assets, but however, because we are consumption of this, so this is also included in our GHG accounting. Now, the last one is the more interesting one and somewhat related to what I mentioned in terms of the asset data framework. Now, this is the indirect emission that occurs during a company's value chain. So in this case, we're delivering a greenfield environment. So we do purchase a lot of equipment, there's a lot of construction going on, and the consumption of material to build those water assets. So that in the context of capital project delivery, and what we have been focusing on is exactly on the scope 3 of being able to use digital twin as a method to capture the scope 3 of the emission that occurs during the company's value chain in the equipment and material usage. So and again, coming back to that stage gate process of delivery. Now, what we have assessed is that we needed to put a specific requirement in early, especially at the initial stage of doing the master planning of our assets. And this is an opportunity where we're able to insert our specific requirements on the life cycle carbon specification and cascade down into our PMCs and the contractors, and that where the accuracy of assessments that we found to have implemented that at the initial stage really has a big impact on the ability to really accurately capture the carbon value. Now, it is based on our experience, it is difficult to capture the exact the value of carbon emission. And however, by taking this kind of step-by-step approach and also to insert the requirements early, we found that this really provides a kind of accurate platform for us to analyze this. Now, so what does this entail? So we established the NEOM standards, and based on the standards, we provide a number of estimation. Now, in order to accurately measure the carbon emission and to expose the requirement, we had to expose the requirements to the supply chain, and we do that at the early stage. So that the data produced by the supplier, this is where we relate to the C4 standards. So in the C4 standards, we have inserted a number of required attributes and data sets, and we put those out there as part of the project information requirements. Now, this becomes a mandatory submission by each of the data suppliers. So this includes EPC contractors as well as vendors. So in addition of providing the equipment, they also produce data sheets, and inside data sheets would contain those specific values where we needed to measure the carbon emissions. And then in this digital twin environment, we're able to then reflect that into a report. And as you can see from this particular screenshot, that we're able to hotspot some of the major areas that contains high value of carbon data. Okay, so that was a very quick overview of our digital twin environment and the some of activities that we are currently implementing to capture that greenhouse gas emission and carbon value data. And again, thanks to our technology partner, here's a QR code which links to a published content on LinkedIn that has a bit more detail on everything I have just described. So yeah, please feel free to scan the QR code and yeah, read more about it. Okay, thank you very much.
Excellent. Thank you so much, Min. Well, there you have it, everyone. 3 amazing case studies that really brought in digital twins and energy conservation. We'd love to hear from all of you and hear some of your questions on these amazing presentations. We do have one question from Ben. He's asking Sharon, what do you think about addressing the multiple dashboard problem, which I can imagine a lot of digital twin case studies will be dealing with. So Sharon, do you have some thoughts on that?
Sorry, could you repeat the question, please, Shana?
Yes. What do you think about addressing the multiple dashboard problem? So you are collecting a lot of sensor data, you are looking at a lot of different things in order to make your data-driven decisions. And sometimes utilities have quite a few dashboards from the different systems. So is there a way that for this particular project, you're able to concentrate into a single dashboard, or do you have several dashboards from different systems?
So I think it is a real problem that probably everyone has to a degree. So what we've seen in our control centre as we've grown over the years, we've seen new systems come in, but they're standalone products. And now what we have is a situation that we have got a number of separate systems with different logins, you know, and it's really quite cumbersome for our operators. About 8 years ago, we managed to build a system in-house that we call situational awareness. And that essentially is a dashboard view with a number of our systems integrated into that. And that's been really good because that gives us information from our assets, but also gives us visibility of customer contacts that we have, where our fleets of workers are, also where we've got open work orders, etc. So that has been really beneficial and has helped our operators get a clear, holistic view of what's happening across the country. Now, what we don't have is integration of some of the newer technologies, and in particular the digital twins, Aqua Advanced, etc. They are separate at the moment, and we're working with our digital partners to look at how can we bring all of this information in to build a view that in my mind needs to look almost like a bit of a smart city dashboard, to start to integrate different pieces of data from different systems. I don't have the answer, but I know that it's something that we have to address, or it's just going to become even more cumbersome, you know. So for me, that is one of the key objectives that we've got as part of our transformation, is how we can bring data that we've got into one singular view.
That's an excellent answer, Sharon. I think this is a problem that most utilities have to face. And it's interesting that you are actually able to integrate some of those systems into your homegrown dashboard so that you can get that big view of it.
Yes. I think the last thing I would say is we need to have a clear strategy about how we are going about bringing in new technology, you know, starting to drive change in how we do things, and not looking at all of these initiatives separately. We need to be looking at what is the overriding thing that we want to achieve here. And I think joined up leadership and having an aligned strategy is something that's absolutely critical to that.
Absolutely agree. And I'm hoping all the vendors out there listening, you know, this is, you know, this could be made much easier with APIs. So hopefully many more vendors will start implementing APIs so that it is easier to integrate some of these different separate systems into a single view or a single dashboard. So that's excellent. All right, we have some more questions for you, but let me move on a little bit to Otto. one of the questions is, how are you controlling the nitrogen in your wastewater treatment? DO or ABAC? And you might want to explain what DO and ABAC is. And that's from Shri.
Okay. Well, at least what differs from the way we control compared to local control is that we make use of predictions and also learned relationships to determine the set point. But the fine-tuning and adjusting of the set point we do based on ammonium, but also adjusting for DO values as well. So running that within constraint and also including values for nitrate and phosphate, but that also depends on which instrumentation is available on a specific plant. And the exact control strategy might also differ from system to system.
Okay. And I have a follow-up question for you. So when you were working on this automated control, was there a period of time where you were taking in the insights from your digital twin and manually controlling it and, you know, gaining the trust in those insights before you moved to automated control? Or was it easier to move straight into automated control?
Yeah, so during a project implementation project, we, as soon as that we can place the application, it starts retrieving the data, ingesting the data, and starts learning the patterns and learning relationships. Although in the beginning, because you learn what then also is going on without the more advanced control. Yeah. Still, you start learning the patterns and relationships, and often we see that we can for pre-control we might need some weeks to gather that data. But once we have learned those patterns and relationships, we can start controlling at the beginning together with operators. Sometimes we start during the day, that we can get familiar with it to see the response and tweak and tune that everything works fine. And then if the confidence is there, then we can also start running it 24/7. And I think the applications, because it's always relearning and adjusting, and that more automatically and autonomously, is that afterwards you don't need a lot of intervening, and that's also for them that they can rely on it, that it works in a way that it's not like the chance something now we have to relearn everything completely. That's not the case. I think that's what's also necessary to build the trust of the operator, that it's not that external intervention is necessary to adjust what's learned by algorithms.
No, I agree wholeheartedly. Is you know, because we always talk about technology and then the people aspect of deploying technology, and like you just said, you have to gain the trust of the operators, and that takes a little bit of time, a little bit of experience, and then but
it must be a friend, the advanced control, and not something that's placed and for them a black box they do not understand.
Yes. So walk them through the entire process. So
exactly.
Excellent advice. And let's move on to Min. Min, you talked a lot about the asset management and the asset properties. Are you getting a lot of the carbon emission information from the manufacturers, or some of that through life cycle properties as well of the assets?
Yeah. Okay. Good question. So a lot of those is actually from the life cycle property itself. So that's a kind of the short answer. But yeah, it is, as I mentioned earlier, that it is not easy to capture the exact value of carbon emission. And as part of that process, this is exactly kind of why we introduced that CFOS framework, right? So with that framework, you're able to insert many different type of properties based on the business needs at the time. And very similar to you discussed earlier, that this is also very much related to a people process, because you first need to educate the contractors out there to be able to submit those information and in a structured manner, so that we have developed three sets of kind of initiative to be able to ensure that we get the information that we need. Now, first of all, we looked internally into what is exactly the target we want to achieve, what is realistic to measure. And then those requirements internally that we looked at turns into our specification and procedures. Now, next, we're able to run a number of, if you like, educational sessions, and we refer to as the Innova Water Academy. Now, through that, we gathered our the contractors and PMC that we worked with, and be able to educate them on our requirements and specifically on those life cycle data and attributes. Now, with that kind of understanding, the system itself was also providing a level of measure and also a level of kind of that control to be able to have this constant input of that information into the digital twin environment. So yeah, it takes very much kind of people, process, and technology to really capture those information.
Yeah, no, that's very exciting, and it's very exciting that you're doing this in a green field, so you could see it from start to finish. All of these categories. I'm sure we're going to continue to learn a lot more as you continue to grow NEOM. So thank you for that. I have a question here from Emily. I'm interested to hear more about the back-end database management. Is this using the SCADA Historian, Equus, or other software platforms? And I think, Sharon and Otto, maybe you would both want to take a little stab at that.
So,
Sharon,
yeah, so Sharon here. So Emily, I would love to say that I'm an expert in all things SCADA. Sadly, that's not the case. However, what I would say is the way that we are set up just now, we have got 3 separate telemetry systems, and that gathers lots of information in from our SCADAs out on the asset. Now, at the moment, a lot of that information is separate to other information that we are getting through IoT devices and smart devices. So at the moment, there is a lot of challenges that we have trying to make sense of the data that we're getting in, and a lot of that is to do with the naming conventions that we have. The coming together of 3 separate water authorities back in 2002. So a lot of the information that we have does come from SCADA, but predominantly on our telemetry. I don't know if that's helped with this any, but it's definitely something that we have got a lot of focus on just now. We've already got some work happening to move telemetry data into our Azure cloud to make it much easier to join all of this together.
And thank you, Sharon. Yeah, no, it's a very complex area, and it kind of goes back to some of the things that Min was saying about the digital thread, that you're collecting data from all these different systems, and sometimes they have different naming conventions, and you're going to have to use a human being in the middle in order to map those different assets and collect that information. So it's a complex environment, but hopefully we're going to continue to make it easier and make it easier to deploy digital twins in most of these situations. And Otto, what about you? Did you have, are you using a SCADA Historian as well with your digital twin?
Yeah, so for control purposes, you need real-time data to act on. But yeah, it really depends on the SCADA or PLC system that's there at the plant or at the pumping station. And of course, yeah, you need some sort of standard module with which you can communicate via different protocols with those systems. And what we there do is that we can provide solutions for several types of systems with different protocols, but that at the end, the whole setup of the further digital twin is not influenced by the fact that you always have to connect to different types of systems.
Yeah.
So in that sense that you make it modular. But yeah, indeed, sometimes it's a bit puzzling how to connect with maybe new system, but yeah, those are issues easily to overcome. And yeah, there are all standard protocols with which you can communicate. Then once that's arranged, you can use the data within the application.
Yeah. Well, hopefully that answers your question, Emily. Thank you so much, Otto. I think we're at the top of the hour. Shayna, this is where we need to probably be wrapping up, correct?
Yes, correct. And I want to thank everybody for joining us today for this webinar. And you will be able to find the recording and some of the insights shared on the SWAN website later on. But in the meantime, have a great rest of your Valentine's Day. And yeah, thank you all. And
Thank you all.
again
Thank you to the speakers. Excellent talks. Really learned a lot today. So thank you.
Thank you.
Thank you, everyone. Thank you.
Thank you.
Bye-bye.
Bye.
Bye.